Hello and welcome to Food Physics Mid-Year Edition. Karamihan sa inyo ay nais malaman kung ano nga ba yung magnetic properties na meron sa food maliban sa obvious fact na merong iron in small quantities ang ibang mga pagkain at ang iron ay isang mineral na kailangan sa pag-function ng ating katawan. So if you want to find out, join me in this next hour or so as we explore magnetic properties of foods. Alright, so you've probably never seen a food material with enough magnetic properties, so to speak, na magre-react siya kapag sinalpakan mo ng magnet as you can see in that looping animation below, no? But in reality, materials on a food and non-food can be classified based on their magnetic properties, okay? And even organic molecules, no, hindi mo kailangan maging metallic element with a positive charge sa periodic table para magkaroon ng reaction sa magnets, no? So even organic molecules again respond to magnetic forces. And we also have this term called magnetic permeability, which is defined as the extent to which a material can become magnetically polarized. So in short po, hindi porket hindi mo nahihila ng magnet yung isang food material or yung molecules nito or wala kang visible attractive force na nakikita ay wala ng magnetic properties ang isang, well, in this case, pagkain, no? So the thing here is you want to identify the magnetic properties of that food to be able to classify it, and you want to be able to measure yung mga magnetic related properties na yon, quantify them, despite the fact na hindi sila visible sa naked eye na kapag minagnet mo ay lalapit sa'yo yung pagkain. So there are three major classifications when classifying foods according to their magnetic response. These are paramagnetic, ferromagnetic, and diamagnetic. So we will look each one of them in turn in the next few slides. So let's start with paramagnetism. These are substances that have a weak attraction to an external magnetic field. So perhaps if you put these near a magnet, you would feel some weak attraction, but not a strong one that would cause it to stick. Okay, so we have what we call Langevin, or if you prefer French, Langevin paramagnetism, which involves having a permanent magnetic momentum because of having unpaired electrons. An example here would be aluminum. So, hello chemistry days. 1s2, 2s2, 2p6, 3s2, 3p1. So as we can see here, dito walang pair yung electron mo. Okay. So, that gives it a certain direction. Dahil wala siyang ka-pair, pwede siyang ma-attract sa something. Okay, salita ako ng salita kanina, hindi pala na-record. So anyway, continuing on with the aluminum from the previous slide. So we can see here the unpaired electrons. And kapag nilapit mo siya sa isang magnet or source ng magnetic field, then those unpaired electrons align themselves accordingly to the magnetic field. However, when you remove the source of that magnetic field, they come back to their random go anywhere state. There's also what we call polyparamagnetism, which is the excited conduction of electrons in metals, such as alkali metals and noble metals in your periodic table. So, we also take note that the paramagnetism, yung phenomenon na ito, decreases with increasing temperature. So, as you know, if you increase the temperature of something, you increase the enthalpy and its internal energy, and therefore those random motions will be maybe faster or more frequent. So mas mahirap silang i-align with a weak magnetic force reacting. Alright, so let's move on to ferromagnetism from the word ferrous or iron. So Kasi ito naman yung pinaka-obvious na pag naglagay ka ng magnet, didikit yung iron. But this also includes cobalt and nickel, which are neighbors of iron in the periodic table, as well as some rare earth metals. So in ferromagnetic materials, they contain elemental polarized atoms aligned with a fixed orientation, also called Weiss regions. So although individual regions differ from each other kung saan sila naka-orient, kapag nag-apply ka ng magnetic field, etong mga individual aligned regions na ito ay magkukumpol-kumpol and in the direction of the magnetic field, while the unaligned regions versus the direction of the magnetic field will weaken and or disappear. And as with all types of magnetism, when you increase the temperature, yung magnetic effect niya ay nagde-decrease, and we have this Curie temperature wherein magnetic properties nung even your ferromagnets would disappear if that temperature is exceeded. Then we have diamagnetism, which is characterized by having atoms with paired electron spins. No? So meron sila nung up and down arrow dun sa kanilang electron spin, and therefore it has no magnetic momentum, and as a result it will be unresponsive to an external magnetic field. Okay. It also has what we call the diamagnetic effect, where it actually, aside from being unresponsive to a magnetic field, weakens that magnetic field near it. And the subatomic level effects are, on one hand, temperature independent. So we also have a phenomenon called antiferromagnetism, wherein it displays an apparent diamagnetic property, and this is applicable to the magnetic moments of non-paired electron spins in antiparallel orientation, such as those in the oxides of iron, manganese, and chromium. And the bottom line here is that no magnetic polarization develops. Also, antiferromagnetic materials change to a paramagnetic behavior above a certain temperature known as the Néel temperature. So here we have a handy summary of the three basic classifications of magnetism, differentiated by factors such as the presence of dipoles, electron spins, ability to amplify magnetic fields, diamagnetic effects, and some examples. Of course, as of now, you might be asking, yung iba dito wala namang technically kinalaman sa pagkain. You don't eat lead and copper, right? Although some of them may exist as food contact surfaces, but we'll see throughout this lecture kung ano pa yung silbi ng magnetic properties in food classification. We probably discussed magnetism in high school, but probably just as quickly forgot about the explanations. Although you would probably have experienced magnetism firsthand or played with magnets as a child, either with toys such as ones figured here, or by breaking down your old electronic devices and finding out that there are magnetic materials there. So there's a video link here you could watch to understand simple explanations of a magnetic field. But basically, we know this and we observe this, that when you have a magnetic material such as these permanent magnets, no, ferromagnetic materials that have been exposed to a magnetic field and have become magnetized in the process. So they have an influence in the area around them, such that when you place materials such as iron filings that are ferromagnetic or affected by a magnetic field, then they would form these sort of magnetic field lines, as you can see there. Okay, so basically a magnetic field therefore is just a description of a condition in space in which the moving charges experience a force perpendicular to their velocity, and this moving charge therefore is the magnetic field. So it doesn't necessarily mean that electrons fly in the direction of the arrows, as you can see here, or whatnot, regardless kung may nakapatong dyan. But when you have yung mga electrons nandun sa materials mo, they would be say influenced by this field to move in a certain manner and thus align themselves and ultimately align the whole iron filing or piece of metal to a certain direction. So magnetization is commonly expressed with the simple symbol capital letter J with units in volt-seconds per square meter, which is a measure of how a material responds to or is affected by an applied magnetic field. So aka kung meron kang bar magnet dyan, tapos meron ka iba't ibang materials, so depending on this value, kung gaano ka lakas yung effect ng magnetic field sa material na yon. We also have the mu, which is your magnetic permeability, or which is a measure of the field amplification ability of materials, and this is simply a value which is 1 if it is in vacuum. And the alternative unit, capital letter B, is sometimes used. So it's expressed in Tesla meter squared or J per ampere meter squared or volt second per meter squared. Okay. So, and here is the relationship between your B and your J. So J is simply your delta B, and B versus B naught is simply influenced by your mu. So take note, yung B naught mo is basically your B in vacuum where mu is equal to 1. And the magnetic field is in amperes per meter. Magnetic susceptibility, also called the relative permeability, is also a measure of the magnetization of the material or its ability for field amplification. And it's simply, as you can see here, your mu minus 1. So parang if 1 represents the mu in vacuum, so parang ninenegate mo lang yun, hence the relative term. No? So this relative permeability or magnetic susceptibility does differ depending on the magnetic classification. So for diamagnetic materials, these are those with a mu less than 1 and therefore an x less than 0. Paramagnetic materials, the mu is slightly greater than 1 and x is slightly above 0, while ferromagnetic materials have mu values much greater than 1 and x values very much into the positive realm. So for example, in vacuum, the mu is 1, air is almost 1, water at 20 degrees is almost 1. However, common steel has a mu of 100, therefore nasa ferromagnetic siya. So in the next slide, we'll see more examples. So as you can see here, obviously, ito yung mga nandoon sa ferromagnetic na category. Okay? Much greater than 1 yung x. Much greater than 0. Then those with a negative x value, of course, are your diamagnetic materials. And those that have a value slightly greater than 0 would be your paramagnetic materials. Okay, let's look at the phenomena called hysteresis, which is related to the ferromagnetic materials change in magnetization and respond to changes in field strength. By the way, this is supposed to be J. Okay, so as you can see here, no, in the past we increase the magnetic field strength, may corresponding increase sa magnetization. Pero when we decrease the H, it doesn't take the same path in terms of the decrease in magnetization. So merong parang residual magnetization na natitira even if we reduce the field strength, right? So this remanent magnetization is defined as the amount of magnetization retained upon releasing the magnetic field. And we also have what we call the coercive field strength, which is the H-axis intercept, or the H value required for zero remanent magnetization. Mag-zero out yung J. So as you can see in this case, for example, um, you need an H value around here para mag-zero yung J mo kapag pa-increase ka. Pero dito sa kabila, mas mababa. Okay? So, kaya parang dalawa yung intercept mo, isa sa increasing, isa sa decreasing. Anyway, remanent magnetization is useful for memory storage devices if you are familiar with, no, na merong mga um, tawag dito, mga devices na magnetic memory yung gamit nila for storage, no, they encode your bytes or bits of data using magnetic fields. So ito yung isang use ng remanent magnetization. Okay, and it's also useful for your permanent magnets in your electric motors. So this is not directly related to food, although just to see, we have two types of magnetic material, being yung soft, literally, and yung hard materials. So in terms of field strength, the hard materials have higher field strength, and it's harder to change their magnetization, so it would require more effort to do so. However, they are also more durable in terms of well-being, physically durable, and the way they keep their level of magnetization. And common applications for the soft materials include those in transformers and your electronic data reader and writer heads. Whereas the hard materials, some examples are your permanent magnets, especially in motors. Then sa speakers, di ba minsan may napapansin din kayong magnet dun sa likod. And your magnetic tapes, which are usually used to store data magnetically. So some of you mentioned that you had a hard time thinking about what would be the applications of magnetism in food, except for the fact that some foods contain iron. Definitely, this is not all direct, no, but when you're using assorting food packaging materials, the use of magnets help separate ferromagnetic materials from other materials, no? And as I've mentioned before, in hazard analysis critical control point, metal detectors are usually one form of CCP or critical control point because there are many metallic objects in your production that can unintentionally or intentionally, kung sabotahe, go into your food. Okay. Then we also have methods that make use of the magnetic properties of your food to classify or analyze a food. So this include electron spin resonance spectroscopy, electron paramagnetic resonance, magnetic induction flow meters to read your fluid flow, induction heating, and microbial inactivation. And we will be also discussing one major method used in food analysis related to magnetism in food. And that is NMR, or nuclear magnetic resonance. So in a nutshell, because your atoms have magnetic properties, a nuclear magnetic resonance machine can make sense of the chemical structures of the components of your food, okay? And with proper training and calibration and yung database ng machine mo, pwede mo siyang magamit for either identifying or quantifying kung ano yung meron na mga components sa iyong pagkain. So this is based on the principle that yung magnetic properties Your components have magnetic momentum based on their electron spin, and you have your mga mass numbers and protons that differ from each element. Okay, so as you can see here, so there are 4 examples of elements with the differing number of protons and mass numbers, whether odd or even, and kung meron man silang magnetic moment. So for example, so you have fluorine with an odd number of protons and an odd mass number. So it's called an odd-odd nucleus and has a magnetic moment. And for example, on the other hand, you have carbon-13, which has an even number of protons but an odd mass number. So it's an even odd nucleus and it has a magnetic moment compared to your carbon-12, which is an even nucleus and without a magnetic moment. So as you can see here, excuse me, yung type of nucleus nila could be classified dependent on whether odd yung number of protons or even, saka kung whether odd or even yung mass number. And this would of course dictate kung may magnetic moment siya. Generally, if it's odd-odd, sorry, kung even-even, wala. No? And here you can see an example of an atom with a magnetic moment, okay, showing the dipole and the north and south poles niya. So that explains the nuclear part, no? Yung mga bagay na may kinalaman sa nucleus. So how about the magnetic resonance part, right? So we know for a fact that when atoms absorb energy, yung electrons nila ay pwedeng mag-jump ng energy state, no? Tapos, well, what happens is when you have magnetic fields, so yung mga sensitive sa magnetic field ay magkakaroon ng difference doon sa energy state nila versus kung wala yung magnetic field. So as you can see here, alright, so kapag may magnetic field, ito yung itatalon nung state ng electrons mo. Kapag wala naman ay ito lang. So there's an energy gap, so to speak. So, okay na tayo sa nuclear part and sa magnetic part, na naman tayo sa resonance part. So, when your material, which consists of ultimately of different atoms, is bombarded with electromagnetic waves of a certain frequency, so may point doon na marireach mo yung resonant frequency ng, let's say, isa sa mga atomic nuclei doon. And of course, that will be read out by your equipment. Pipick up niya yun. Okay, and that would tell us something na because the resonance frequency depends on both the magnetic moment and the chemical composition of, let's say, your molecules, no? So that would give us a sort of a footprint, fingerprint, okay, by which to make out kung ano yung mga components doon sa sample mo. Okay, no? So in this regard, if you look at the schematic, it's in a way not much fundamentally different from, let's say, your spectrophotometric methods which you've used in chem or food chem, no? So again, you have a magnet here. Your sample is connected to the receiver coil, which is connected to the computer, and you have a radio wave transmitter, no? So sa radio wave transmitter nang gagaling yung varying frequencies, and obviously the magnet would have something to do with the magnetic field, and your 3 and 4 would then be used to calculate na and measure yung mga kung anong nangyayari sa loob na based on sa frequency and magnetic field yung mga tangible responses ng nuclei, ng mga electrons na nagjo-jump ay nire-record dyan. So at this point, you're probably familiar with light spectroscopy. I'm not sure if you've already discussed AAS in your food chem. but they have similar principles, no? Um, in most yung sa AAS and light spectroscopy mo, you excite electrons in atoms. However, in NMR, you excite the atomic nuclei within a magnetic field. You do the excitation sa AAS by temperature, sa spectroscopy by light, and sa NMR by using radio waves. And dahil doon, naka-quantize yung energetic states of electrons for the other two forms of spectroscopy and the atomic nuclei naman sa NMR. Okay? Both light spectroscopy and NMR measure resonance frequency, and all of them measure the absorption, okay, of your electromagnetic waves. And what they analyze, so kapag sa AAS and light spectroscopy, you analyze the emission of light and its frequency. Sa NMR, yung emission ng radio waves and its frequency. Since radio waves are not visible, di ba, sa spectrum ng electromagnetic radiation. And then information in emission is about the electron cloud of the atoms for AAS and light spectroscopy. For NMR, it's the surrounding of the atomic nucleus. So, kaya pag sa AAS, ang nami-measure mo lang is what type of atom. Sa light spectroscopy, you can measure molecules and bonds. And sa NMR, you can elucidate the molecular structure as well and the bonds. No? Kasi we can have one molecule na pareho yung number of atoms of a certain element, pero pwedeng magkaiba yung configuration. So, sa light spectroscopy, hanggang dun ka lang sa molecule. Sa NMR, you can look at the structure. Maybe even go as far as if two molecules having the same, let's say, atomic mass and element ratio but different structures, maybe you can get information on that as well. Right, so you can watch this video and using the link below, which should also be on your study guide, and understand how pulsed NMR works, which also mentioned in passing sa video na ito yung continuous type of nuclear magnetic resonance. So again, in summary, based on the previous video, when you use pulsed NMR, so you generate pulses of light with multiple frequencies, and at the same time, yung generator mo, yun na rin yung magiging receiver, and yun yung magbabasa, and with using Fourier transform, it will display kung ano yung mga resonance frequency based on the pag sa receiver ng pulse. You also have the continuous wave NMR, and as previously mentioned in the video, so it's very similar to yung pag nagsascan yung UV spectrophotometer mo at varying frequencies. But there are two ways to do it. No? You could either scan with the varying magnetic field strength, which is called a field sweep, or scan traditionally with the varying frequency, which is called the frequency sweep. So in terms of resolution, we have what we call the low and high resolution NMR, and you can see the differences in this table. But ang bottom line is low resolution, mas limited yung use niya, kasi limited yung capabilities ng analysis, doesn't do Fourier transform, and usually mas maliit siya na equipment. So, isang application nito sa quality assurance industry, it can do, let's say, analysis of fats and oils at a very fast rate, no? Compared to, let's say, the traditional chemical analysis methods, which would involve, let's say, solubilizing your food sample, etc., etc. Ito, isalpak mo lang siya sa machine and then wait for it, and then you get results. High resolution NMR, on the other hand, since it can detect chemical shift frequencies, then mas marami siyang kayang i-elucidate na chemical configurations, but these are large machines which require helium cooling among other things. So both of them are expensive, but definitely the lowest one is cheaper. And I think some of our local large food manufacturing companies may ganito sa mga lab nila. So for comparison, obviously this one is a low-res NMR and this one is your high-res NMR. Need I say more? So one example of the use of NMR, example in this case, if you want to determine the ratio of liquids and solids in a food sample, so in this case, the protons in the solid phase have a shorter relaxation time compared to those in your liquid phase. So from the graph of over time, pwede mong makita yung differences nila. So tangible examples of use include for in-quality control, profiling of various chemical components na meron siya. Therefore, in a way, kaya mong i-fingerprint yung, let's say, in this case, apple juice from different varieties or green teas based on place of origin. You can also quantify metabolites. You can use it for food authentication. Since kahit ma-fool mo yung lasa ng tao, you cannot fool yung chemical structure niya, di ba? On the molecular basis. It's been used in the controversial determination of melamine in food. No? If naabutan niyo yung issue ng melamine in milk years ago, NMR could be a viable method to determine melamine contamination. It's also a non-destructive determination of changes caused by heat treatment. So, yun yung maganda sa kanya. The non-destructive nature means the samples will be kept intact and therefore the analysis will not alter the product in appreciable ways. You can also use it for collagen determination and determination of water holding capacity. So, marami siyang applications. No? Sky's the limit. Actually, ito pa lang isa yung pag-fingerprint or pag-identify ng chemical components. Marami ng pwedeng uses to, no? So here's an example from Parlak and Guzeler. Okay, isa siyang NMR spectrum of green tea extract. And as you can see, they were able to identify yung mga peaks corresponding to different individual molecules and even more or less quantify kung ilang ppm yung meron dun sa sample size nila. So, ayun, ganyan siya ka-amazing. But of course, the caveat is, to be able to identify this, dapat may database ka, no? So, kasi kung wala, meron kang peak niyan, hindi mo naman ma-interpret kung anong ibig sabihin. So, there are certain cases wherein kung novel yung method, mahirap i-elucidate kung ano yung molecule na nagko-correspond sa isang peak. Okay, kasi tao pa rin ang gagawa nun unless naka-imbento ka na ng isang self-learning AI na kayang gumawa nun for you. Okay?
You probably heard about magnetic resonance imaging from medical experts who may be doing research much. Although its main use is in the medicinal field, it does have some applications for food use. You can watch this video to learn more about its principles.
So some examples of magnetic resonance imaging is used in food. So pwede nilang real-time live makuha yung moisture content ng rice habang niluluto ito. Okay? You can also look at the three-dimensional temperature distribution during microwaving because as you will learn dun sa electromagnetic topic natin, yung microwave hindi naman very even yung pag-cook niya ng mga bagay dun sa loob, no? Because it depends on dun sa pagtalbog-talbog ng mga waves inside the vessel or chamber. You can also look at the meat fat content and distribution of meat fat. In the same way na ginagamit siya sa katawan, ang tao pwede rin siya gamitin sa katawan ng hayop. And lastly, you can monitor changes during freezing, cooking, and food processing, such as water redistribution during apple freezing or salt diffusion during brine curing. So as you can see, yung applications nito ay merong mga magandang as long as creative ka, no, yung mga real-time na pwede mong tingnan na changes dun sa migration ng chemical components mo or maybe changes. So pwede mong makita yon, no? And your creativity is the only limit and your budget as well, syempre, kasi kailangan mo ng MRI equipment na specific for your application or at least pwede siyang gamitin doon. Okay, kasi yung MRI sa mga hospital, ginawa yan para sa katawan ng tao, no? So, there, and this is the last slide for our lesson on magnetism, although we do have a separate topic on electromagnetism and electricity or electrical properties.